Alright, so this is going to be the Chapter 8 Learning Target number 1 video. This is, should be, hopefully you're doing it right now, it's over the weekend, so this is the first target of our chapter, and it's all about equations. Okay, now we already talked about yesterday, on Thursday, we talked about the difference between equations and expressions, and, equations have an equal sign, so, x plus 2, that's an expression, but if you all of a sudden make it that, now it became an equation. And we know that the verb we use when we're talking about equations is to solve. We solve equations. We can simplify or evaluate expressions. So we would solve this, and the word solve means figuring out what an unknown is. Okay? Alright, so a lot of this stuff is going to look very, very review because we've been doing it in class, so I just hope that you remember some of this stuff because we have already spoke about it. First thing would be inverse operations. Inverse operations are two operations that undo each other. It's exactly how I taught you to understand it, such as addition and subtraction or multiply and divide. Multiply and divide. Okay? Equivalent equations are equations that have the same solutions. Okay? Which is pretty obvious. Okay? So you can see, I really like the way our textbook does this. This is from our textbook actually that you guys can get online, but it basically shows it as a seesaw. That's essentially what it shows it as, and it's pretty cool how it shows it. So the little squares you see there, I'll kind of X one off so you knew what I was talking about. One of those is representing counters. Like when I say counters, that's just something you count with, okay? And then the other one represents the X counters. So we don't know how many counters that is, so we kind of put it as a longer shape than that. I mean, it could be 2, it could be 3 of those, 4 of those, 5 of those. We don't know. So, this one here, this problem right here, this equation, I'll rewrite it. X plus 5 equals 8. That's how they're representing it. So again, you can see the little cone thing that they have. They're showing it as a balanced scale. Same thing. I mean, oh boy, I don't even want to try to spell seesaw. Oh, duh. Maybe it's like that. I don't have any idea. It probably something like that. But regardless, teeter-totter, seesaw, balanced scale. But that's the whole point, is because since equations are equal, you know that this side has to be equal to that side because it's balanced. It's perfectly balanced, so they are equal to one another. So we have 8 counters here, because that's this 8 right here. And then we know we have these 5 here, as you can see. And we want to solve it to figure out, well, how many counters would X be then? Okay, and you would solve this, and we're going to do it because this is a real basic one, but we're going to do it anyway because every time we solve an equation, I expect you to do it this way. We're going to draw a line, and the line again just kind of represents this. It's just kind of drawing a line from separating the left side of the equation from the right side, and then you just ask yourself, and I'd like you all to write this so that we can learn it. What is happening to the variable? Okay, I'm going to ask you that so many times over the next 2 weeks. It's not even funny. That's what I want you to think of. Okay, and in this one, when you ask that question, hopefully you'll answer it by saying, "Oh, well, if I'm adding 5 to the variable, then I need to undo adding 5." Now we can go up here and see inverse operations are two operations that undo each other. So if I can add 5 to this, that means I'm going to subtract 5. And then that leaves me with just X on the left, okay, because X plus 5 would be whatever, but then if you take away that same 5, you're basically canceling it because, like the example I gave you, I have X dollars. If I got $5 added to it, but then took the 5 away, I'm now back to my X dollars. So this process right here is called isolating the variable. We want the variable to be all by itself on the left side of the equation, or the right side, but since it was on the left to begin with, we want to keep it on the left. Okay, now remember, in order to keep a seesaw balanced, I gave you this example, but if all the kids weighed the exact same and you had 2 kids on the seesaw, or 3 kids or whatever, and then you had 3 kids on this side and it was all balanced, all perfectly balanced. Okay, if I went over and subtracted 2 kids from this side, the only way to keep it balanced would be to subtract 2 kids from this side. Or we can think about it a little bit differently. If I went over here and said, hey, I want these 2 kids to be added, so I'm going to add 2 kids to this side, I've got to add 2 kids to this side as well because then I've got 5, and we know that 5 is equal to 5. So you must do the same to one side that you do to the other. So there's where I get x equals 3. And then you should always take it and plug it back in just to make sure that 3 plus 5 does equal 8, and it does. Okay. This one is showing multiplication. So it's saying 3x, 3 times x. If we were solving this, which we're going to right here, we are saying, okay, what is happening to the variable? Well, x is being multiplied by 3, so we're going to want to divide by 3, and we're going to find that x is going to equal 4. Okay? That's how we know that. Okay? Let's go to the, well, actually, yours, I'm on the next page. Your guys is just right below it. But okay, example number 3. Another addition. You can see the x, the long bar representing x counters. We don't know how many that is. Okay, but we do know that we've got at least 6. We got 6 on there, and we know 9 are on this side. How many are missing on this side? Obviously, you guys would all probably be saying 3, but let's continue just to practice solving the right way, because as I've told you a billion times this year, it's more about the process than it is about the answer. Okay, and then we ask ourselves, what is happening to the variable? Well, we are adding 6 to the variable, so I need to do the inverse of adding 6, which is subtracting 6, which would leave me with x equaling 3. We take that and plug it in. Is 3 plus 6 9? Absolutely. Okay. Well, this is just showing that it's showing x plus 6, and then if you just subtracted 6 from one side, okay, like, see, we subtracted it from both sides, but if we'd have just done it from one side, then do you see how the balance would tip up? Because if you subtracted 6 here, you got to do it to this side in order to keep it balanced and make it be the same. Okay, so we've already seen all this, so I'm going to skip through it because we've done it in class. All right, and then there you go. That's what we just did. They subtracted 6 from both sides. Now, I usually show mine below it, as you guys just saw. I show the minus 6 happening below it and below it. They just showed it beside it and beside it. Okay, same difference though. Okay. All right, now let's do some practice. Actually, I would like you guys to go ahead and try these 3. Try these 3 at the bottom. See if you can do them, and then watch the video to see if you got it right. Okay? Hopefully you've already done these. You better have anyway. Okay, first of all, I've drawn my line just separating left from right. Now I'm going to ask myself, what is happening to the variable? Well, 6 is being added to the variable, so I need to undo that by inverse operation. So I'm going to subtract 6. Of course, I'm going to do it to both sides. By the way, the reason that this line right here is there is, I said this the other day, but it's because when you do 13 minus 6, if I were to ask you to do that in real, like not in equations, but just in general, you would come up here and you would do it like that, and you would draw this line right here. That's how you've always done it. So that's why that line is there. That leaves you with P on this side. Put my equal sign back in. 13 minus 6 is going to give me 7. Now remember, most important part here, take that number now and take a second to plug it back in, just to be sure that it does indeed equal 13. And it does. 7 plus 6 is 13. Okay, here we draw a line. We're going to put in minus 4. Minus 4. That's going to leave me with R equaling 8. I'm going to take that 8 and I'm going to just plug it in just to be certain. And 8 plus 4 is definitely 12. And finally, this is the one hopefully nobody messed up, but I'm sure some did. You ask yourself what is happening to the variable. And 10 is being taken from K. So I need to undo 10 being taken from K. I see a lot of people doing this, and this is wrong, by the way. I see them subtracting 10 and subtracting 10. Okay, you can't do that, because if you're already taking 10 away and then you actually take another 10 away, really what you're doing then is you're doing K minus 20. You're taking 20 from K because you just took 10 twice from K. Okay, so remember, you got to do the inverse of whatever's happening, which is adding 10 and adding 10. That's going to give you K equaling 17. Take it and plug it in. Is 17 minus 10 7? Absolutely. Okay. Okay, now we got some multiplication. Same thing. I'd like you to try these real quick. Okay. First of all, we're going to draw a line down through here, and I ask myself what is happening to the variable, and I see that the variable is being multiplied by 2, so I've got to undo that by dividing by 2. Okay, which leaves me, just think of it like this. I have 2 monkeys, and I'm dividing them by 2. Okay, but anyway, 2 monkeys divided by 2 would equal 1 monkey. I mean, so remember, just because it's not there, there is a coefficient of 1 there, though. Okay, so that's what we're doing when you're doing the inverse, is you're getting back to just the variable by itself. Okay, then we do 6 divided by 2 is 3. Take 3 and plug it in. Is 2 times 3 6? Absolutely. This one here, I can see that n is being multiplied by 4, so I need to do the inverse, which is divide by 4. So I learned that n equals 5. Plug it in. Is 4 times 5 20? Absolutely. And by the way, just to recap one more time, I want to make sure you're hearing this. These numbers are very, very easy. I expect you guys to be able to do them mentally, but it's more about the process, and this question right here proves it. This is what I'm talking about. I don't believe there's any of you that can just do this as easily in your mind as what number 6 was. So this is where the process is very key. Okay, now we ask ourselves that same question. What is happening to the variable? Well, the variable is being multiplied by 1/5. So I need to do the inverse of multiplying by 1/5, which is going to mean I'm going to be dividing by 1/5 and dividing by 1/5. By the way, just to, before people start commenting on this video or on the Schoology page, I know I said we don't use that sign anymore. Okay, I know that, but the reason I do it for this is because if you put a line there and then a fraction, it just gets kind of sloppy. Okay, so I can't really put a line. I mean, you could put a line there. I wouldn't count it wrong, but I think this way just really makes it easier. The other thing I want you to notice is, do you notice how I put 1/5 up here beside 3? And the reason I did that is because now I'm all set up here and ready to do the algorithm for division of fractions, right? I know that the dividend, the first number, stays the same. Divide is going to become multiply, and I'm going to use the divisor's reciprocal to get 5 over 1. Okay, and that's going to be 15 over 1, which equals 15. Okay, so that's kind of the way I do those, and I think you guys should as well, because it'll really help. So you don't have to come over here and then rewrite it over here. You only have to write it once. So I know there's a little differences between each one, like whether it's multiplying, dividing. There's like a little different process, but you guys will get it with time and practice. So now obviously we need to check this. We never want to not check it, so we're going to do 1/5, and we're going to now multiply it by 15 over 1, and that's going to give us 15 over 5, because I do top times top, bottom times bottom, and I know those both have a common factor of 5, and I'm going to get 3 over 1, or 3, which is what we said it had to be. Okay, so really no reason to miss any of these, because I'm glad I skipped like 40 questions. Sorry about that. I'm sure you guys were all saying, what's he doing? But regardless, we'll come back to him now. Okay. This one here, draw the line. 5 is being added to f, so we're going to subtract 5. So now we know that f is going to equal 9. Okay. Here we go. I draw my line. W minus 6, so that means 6 is being taken from w, so I'm going to add 6. And that's going to equal, W is going to equal 16, and plug it in. Okay. This one here. Oh, I did want to talk about number 10. I'm glad I actually saw this one. Okay. Now, obviously, hopefully you can see what the difference is right away. Okay. In this one, we put the value on the left. We put the algebraic expression on the right. But guess what, guys? Nothing changes at all. What is happening to the variable? Well, 11 is being added to it. So what am I going to do? Well, I'm going to do the inverse of that, which is subtracting 11. And that's going to leave me with 15 equals G. Okay. Now, if you just don't like the way that looks, it bothers you that it looks that way because you like having the variable on the left, here's what you could do. G plus 11 equals 26, and then solve it that way. And I would be perfectly fine if you did it that way, because quite frankly, it does not matter. But if you just feel more comfortable doing it that way, that's fine. And then take it and plug it in to make sure that 15 plus 11 is 26. And it is. Number 12, I don't think we need to do. We'd know that it was just adding 9 and adding 9 to both sides. Okay. All right. Some more practice. And by the way, I'm not going to make you pause these. But if you want to pause them just to try them, it might not be a bad idea rather than just watching, so that you can come in on Monday and be even more prepared for it. Okay? So I know that I look here, draw my line. Now I ask myself, what is happening to the variable so that I can undo it? A is being multiplied by 6, so I want to undo that by dividing by 6. Dividing by 6. Oh boy, 6. Okay, and that's going to leave me with A on the left, 1A, of course. And then 42 divided by 6 is 7. Take it and plug it in. 6 times 7 is 42. We're all good. Okay, once again, this is one of these weird ones again where the variable is on the right side, the expression's on the right side. If you don't want to mess with it and you just want to go ahead and make it 13b equals 65, that's fine with me. If you want to do it that way, do it that way. Doesn't matter, same process. What is happening to the variable? Well, it's being multiplied by 13, so I'm going to divide by 13. Okay? Over here, divide by 13, divide by 13. Either way, you're isolating the variable, and then you know it's 65 divided by 13 equals 5. Okay? Now you should plug it in to make sure that 13 times 5 is 65. There we go. It is. Okay? Alright, I'm glad I got to these ones because I wanted to talk about number 16 and 17. These can be a little bit tricky, but I think the way I'm teaching it, it should make it pretty easy. Okay? First of all, we separate left and right just like usual, and then we ask ourselves, what is happening to the variable? Okay, and I see that the variable m is being divided by 8. So I need to undo that, and that would be multiplying by 8 and multiplying by 8. Okay? So, again, it's just inverse, just like when we up here we were multiplying by 6, so we divided by 6. Well, that's the inverse. Well, here, if we're dividing by 8, then we want to do the inverse, which is multiplying by 8, which leaves me with f there, and then 9 times 8 is going to be 72. 72. And then we should take it and plug it in. 72 divided by 8 is definitely 9. Here's the same way, except for it's just flip-flopped again. But regardless, I can see that n is being divided by 7, so I need to multiply by 7. And multiply by 7. And n is going to be 12 times 7 is 84. Okay? Plug it in to make sure, and you'd be good. Okay? Alright, finally to these ones, because this is where it takes another step. So I just want to do these as practice. Actually, I'd like you to do 31 and 32 real quick, please. Okay? Draw your line. Ask the question again. What is happening to the variable? Well, it's being multiplied by the fraction 4/3. So I need to undo that by doing divide by 4/3 and divide by 4/3. Once again, notice how I wrote it up to the side of it, because I know that any algorithm for division, if I was doing 1/2 divided by 1/4, we always write it going horizontally like that. That's why I put divide by 4/3 there. Okay. Now I'm just going to go ahead and do the algorithm, which is going to be dividend stays the same, divide is going to become multiplication, and the reciprocal of 4/3 would be 3/4. Okay. 36 times 3 I think is 108, but I'm going to check. 108 over 4, and then 108 divided by 4 is going to give me 27. And then you should take that and plug it in. Make sure, I guess I should write y equals 27. Make sure that 4/3 times 27 is 36. So you do that, 4/3 times 27 over 1 gives me 108 over 3, which equals 36. And we can check that. 108 divided by 3 equals 36. Okay? So what I'm really trying to stress to you guys is how it's just the same process constantly. Constantly, okay? Here I can see what is happening to the variable. Well, it's being multiplied by 5/6. So I'm going to rewrite it as divided by 5/6. Now, this one, I'm not really able to write it. You just can't write it up here and do 5/6 divided by 9/10 because that's not the order. It's this number. This is the dividend divided by 5/6. So in this case, you probably have to rewrite it horizontally like this and do the algorithm that way. 9/10 times 6/5. It's going to be 54/50. Okay, which I know is divisible by 2 to make 27/25. Would be your answer. So it would be V equals 27/25, or you could leave it as 1 and 2/25. Either way, you could convert it to a mixed number, but the process does not change. These last two here, 3, this one's just decimals, but it means the same thing. Draw your line. What's happening to the variable? Multiplying by 9.5, so I'm going to divide by 9.5. Divide by 9.5. Okay, and then I'm going to get x, whatever that equals. Okay, 232 7/500 divided by 9.5. Okay, just trying to save time here so you don't have to sit here. I think you guys get the picture. Now this one, I do want to talk about this one for a minute. I see that the variable 1/2 is being added to the variable, so I want to undo that by subtracting 1/2 and subtracting 1/2. That leaves me with x over here. Okay, now I'm going to do 1 3/4 minus 1/2. You could leave this as a mixed number. I'll do it both ways, or you could turn it into an improper and do it this way. But regardless, whether you do it like this or like this, you know you have to have a common denominator. So this is going to have to become 4, and this is going to have to become 2, and that leaves you with 1 and 1/4 because there's no whole being taken away, and 3 minus 2 is 1. Down here, we do the same thing with the common denominator. We end up getting 14/4. Oh, I'm sorry. I multiplied, my bad. 7 minus 2 would be 5/4, or 1 1/4. So what I really want you guys to really see is it's just the same process over and over again. It just gets a little bit more challenging when the fractions get involved. Okay. This last one here, you can see that what is happening to E? Well, 18/11 is being taken from it, so we're going to add 18/11 to both sides. Okay, and that's going to be E equals. If you don't like this format of it being vertical like this, you can turn it to an improper and do 17/11. Just went around the barn there. Plus 18/11, and that's going to give you 35/11 or 3 and 2/11. Either way is fine. And then of course you should check it to make sure that it equals that this minus that would give you that. Okay, so I just hope you guys realize that the process of this whole thing is just the exact same every time, and we started real basic to show you the process, but they are going to become more challenging. So hope you guys have a good weekend. See ya.